Hello and welcome once again to the Maths class, Chapter 2, Circles, Standard 10. Now what if one of the chords is a diameter? For example, like this. The same result will hold since diameter is also a chord and two intersecting chords are divided into four parts and the product of two parts of the first chord will be equal to the product of the two parts of the second chord. So again, PA multiplied by PB is equal to PC multiplied by PD. Let us think of a special case when one chord is the diameter and the other chord is a line perpendicular to it. Let me say once again. Let us think of the special case when one chord is a diameter and the second chord is perpendicular to the diameter. Such a case. Having a close look at the figure, we can see that the diameter divides the chord, the second chord, into two equal parts. Isn't that so? Can we prove it? We have studied earlier in 9th standard, the perpendicular drawn from the center to a chord bisects the chord. Then we can be certain that the second chord CD is equally cut into two halves by a diameter AB at the point P. In other words, PC is equal to PD. PC and PD have the same length. So we had earlier got the relation when two chords intersect. AB is the first chord, CD is the second chord. When two chords intersect, PA multiplied by PB equals PC multiplied by PD. We can change that relation a bit. PA multiplied by PB equals PC multiplied by PC. Since PC and PD are of the same length. This can be further simplified into PA multiplied by PB equals PC squared. Here we can note another thing also. Is it necessary to draw the whole circle since we know that PC and PD are of equal length? What if I draw the semicircle only? Our one chord is the diameter, so it's there in the semicircle, and the other chord is equally divided by the diameter. And PD is not of much importance here in this relation because it's the same length as PC. So we can avoid PD also. So we have a semicircle with a diameter AB and a perpendicular PC meeting at the circle. We know that the same result will hold here. Only we have not shown the whole circle and we have not shown the other part of the chord. But we know that the same relation will hold here. That is PA multiplied by PB will be equal to PC squared. Let us see what we have just inferred. The product of the parts into which a diameter of a circle is cut by a perpendicular chord is equal to the square of half the chord. PA multiplied by PB is equal to PC squared. Here is question number 3. AB is the diameter of a semicircle. P is a point on AB and PC is perpendicular to the diameter AB. As seen in the picture. If PA is 9 centimeters. PB is 4 centimeters. What is the length of PC? Now, such a semicircle is familiar to us. We know here that actually there may be a full circle and one of the chords is the diameter, and PC is only half of the perpendicular chord of the diameter. So here we can use the relation PA multiplied by PB is equal to PC squared. PA is 9 centimeters, PB is 4 centimeters. So PA multiplied by PB will be 9 multiplied by 4, 36. PC squared is equal to 36, or a PC is equal to 6 centimeters.